Hello viewers, this is CS Main 2016 Mathematics Paper 2, question number 2C of Operations Research, and question is of maximization type. Maximize z is equal to 2x1 plus 3x2 plus 6x3. This is the objective function and these two are the constraints which are of less than equal to type, and what is given here that all the variables are greater than equal to 0. So we can solve this problem by the help of simplex method, and further we have to find out is the optimal solution unique and justify your answer. This question is of 20 marks. Now we can see that this question can be solved by simplex method, so we need to write down this question in the standard equation form, and this is the standard equation form where we make constraints as equal to sign after adding the slack variables in the constraints. S1, S2 are the slack variables. So we write down the objective function like maximize z is equal to 2x1 plus 3x2 plus 6x3 plus 0s1 plus 0s2, and subject to the constraints are 2x1 plus x2 plus x3 plus s1 is equal to 5. Similarly, we can write down second one, and all the variables are greater than equal to 0. Before going to tabular form of simplex method, we need to know Gauss-Jordan formula, and these are the Gauss-Jordan formulas. New pivot row is equal to current pivot row upon pivot element, and these the second formula is for all except the pivot row, means for z row as well as other basic variables. So we write down the table for starting table. We write down basic variables here s1, s2, and z row is we have written after taking all the elements to left hand side. So coefficient of z is 1, coefficient of x1 minus 2, coefficient of x2 is minus 3, coefficient of x3 minus 6, and coefficient of s1, s2 are 0, 0, and solution is 0. Similarly, we can write down the s1, s2 row, and these are the right hand sides of s1, s2. Now what we do, we see which one is the most negative in z row. So minus 6 is most negative. This x3 becomes the entering variable, and this column becomes the pivot column. For finding the leaving variable, we have to divide the solution by the pivot column elements, corresponding pivot column elements. So 5 upon 1 is 5, 6 upon 2 is 3, and we select minimum value. 3 is the minimum value. If we get in any case negative value or infinity, we will ignore them. So corresponding to 3, the leaving variable becomes s2. So in next table we see that x2 has left from here and x3 has entered, and what we do, we divide this row by pivot element, that is by 2, and after getting this new row we change the z row and s1 row by using the Gauss-Jordan formula, and after writing all the elements we see again in the z row, is there any negative elements? Yes, minus 2 is the negative element, so this is the entering variable, and now x1 has become entering variable, and this column is the pivot column. So now by writing ratio, that is we divide the solution elements by the pivot column elements, and we get 1 and infinity. We ignore this infinity, and to see the leaving variable corresponding to 1 we get s1, and s1 is the leaving variable. So now we take next table, and here we see x1 has entered and s1 has left. Again we do the same calculation, that we divide the s1 row by the pivot element and get x1 row, and we have written this x1 row. With the help of x1 row we will write z row and x3 row by using the Gauss-Jordan formula, and we get all these values for z: 1, 0, 7.5, 1, 0, 1.5, and solution is 20. Again we see is there any negative value, because it is a maximization problem. So we see there is no negative element in the Z row. It means we have reached to optimal solution, and our optimal solution is 20, and corresponding values of variables are x1 is 1, which is 1, x3 is 3, and there is no x2 in the solution, so we write down x2 as 0. And if we change the solution, then it won't be optimal. Therefore this solution is unique solution, because if x2 will enter, then it will change the solution, which won't be optimal. Thank you.